All right, so last week we started looking at our new unit, looking at electricity. And we found out that electricity is really just moving electrons, right? That part of the atom that had the negative charge, those little electrons, they were on the outside of atoms. And what happens is they can actually move from one atom to the next. So they can flow down a copper wire, for example. And if you have electrons that are moving, then you have electricity. When you turn on the lights in your house, you are allowing electrons to flow down the wire that's in the wall and go through the light bulb, and that's what's giving you light. And same thing in your appliances or your electronics. Right? So electricity really is just moving electrons. Now, how do you make those electrons move? Well, we kind of briefly talked about this last week, and we said that you need a machine called a generator. And a generator is actually a really simple machine. A generator creates electrical energy, electricity, and electrical energy is just moving electrons. But a generator is really simple. It only has two parts. It has a magnet and a coil of wire. So for example, if you took a copper coil and you just went around and around and around, hundreds or maybe a few thousand times, and then came back out again, a coil of wire. And we looked at a little bit of a simulation last week. So here's the simulation again. Here I have a magnet, right? Just think of like a bar magnet that you've probably played with before. And here's my coil of wires. This one only wraps around a few times. Right? Usually it wraps around hundreds or thousands of times. This one only goes around twice. And then the blue dots are the electrons. And normally they're just happy. They're just staying with the atoms that they're with. But when you move a magnet past it, it makes those electrons move. And you'll notice as soon as I start moving this magnet, it starts pushing the electrons in the wire. And if I move it the opposite way, it pushes the electrons the opposite way. But it doesn't really matter which way they're moving. You'll notice that as soon as they start moving, now they're going to go through the light bulb and they're going to make the light bulb work, right? They're going to heat up the filament in the light bulb and produces energy, or produces light. So in this case, well, if you want to generate electricity, all you need to do is just move the magnet back and forth past the coil of wires. Or you could do it the other way around. You could take the coil of wire and move it back and forth across the magnet. And that's all a generator does, is it just takes a coil of wire and it moves it back and forth past the magnet. Pushes the electrons in the wire. That's what gives you electricity. So we said when the magnet moves past the coil of wire, it causes the electrons in the wire to move, or sometimes we say flow, right? It makes the electrons flow down the wire. So almost all sources of energy, of electrical energy, right? If you think about like a power station, all of the different types of power stations, other than solar is a little bit different, but any of the other ones, coal power plant, nuclear power plant, wind turbine, hydroelectric dam, all of those things, we'll look at them a bit more in detail, but all of them involve the same thing. They involve moving your coil of wire past a magnet. So in all of them, what you do is you have a spinning turbine. You somehow spin a turbine. It's just like a wheel, a large metal wheel. You somehow spin a turbine. Maybe you use wind, maybe you use power, maybe you use steam from boiling water, from coal. But you spin this turbine, this wheel. You connect it up to this coil of wires, and you move it past your magnet. And you just keep doing that, and it moves the electrons, and you connect that the two ends of your wires up to the electricity grid, the energy grid, and you can send that to people's houses. And it's a little bit more complicated. There's a lot of details in the energy grid, but this is the basic idea though. All right, so today we're going to specifically look at what are the different options for spinning that turbine. All right, so how do we spin that turbine? Okay, there's a couple things. So one category are called non-renewable sources. So for example, you could burn coal. So you burn coal, you boil water. If you think about a boiling pot of water, it makes steam. If you collected that steam and you put it in a pipe, you could focus it and you could spin a turbine with it. Or you could use petroleum gas. You could use gas to spin a turbine or spin an engine and then connect that up to your coil of wires. Or natural gas. Once again, you could burn the natural gas, boil water with it, make some steam, and use that steam to push the turbine, right? And these are all just different ways of pushing the turbine, right? But as soon as you start spinning it, the coil of wire starts moving past the magnet. You move the electrons, you have your power. So these three sources here, we call them non-renewable sources. And non means not, right? Not renewable. So that means that they will eventually run out. There's a limited amount of coal and gas and natural gas in the world. Coal, for example, coal will eventually be recreated, but it takes tens of thousands of years, so well beyond the life, a human life. So in this case, we say that it essentially runs out, right? Because we wouldn't be able to just wait 10 or 20,000 years for it to form again. So in this case, there's a limited amount of these things in the Earth. When you use them up, they're essentially gone. The other downside of these is that, well, they produce carbon dioxide, right? Which is a cause for global warming or climate change. Why are we using them though? Because they're generally cheap and easy to get. They're easy to move around. They're portable. All right, what are some other options for spinning that turbine? Wind. You could instead just use wind, right? You attach some blades and you spin this wind turbine around and you just connect that up to your coil of wire. That's pretty simple. Hydroelectric. Okay, so you create a dam and you allow the water to flow down and then you add some turbines. Right, so you just add, essentially one of these things in the water, and as the water flows past, it spins the turbine, the wheel, and you just connect that to your coil of wire. The nice thing about the hydroelectric is that you can actually just close it, right? You can block the dam and let the water build up a bit, so you can actually store that water and only open the gate when you need it. Right, so that's the nice thing about hydroelectric. Wind, you just have to rely on a windy day. Another one is geothermal. So this is where you dig way down into the ground, and as you go down, it gets warmer and warmer. And in certain parts of the world, you can actually get steam. It gets hot enough to get steam, and you can pump that steam up and then spin a turbine with it. So these things, wind, hydroelectric, geothermal, we say those are renewable sources because they essentially never run out. Right? You can just continue to have wind and flowing water and heat from deep in the earth. In this case, these things will never run out. These things do rely on the sun. The sun is what causes the wind and the water cycle and things like that. But as long as the sun is around, which is going to be at least for the next 5 billion years, you will continue to have all of these sources. So there's pretty much as you want, right? Now in this case, these things you can't really store, right? I mean, the hydroelectric, you can kind of store energy that way, but wind, you just have to wait for a windy day. Solar is also a renewable source, but once again, it depends on the weather, right? You need a clear, sunny day. So these things we're starting to use more of them, but they're generally more expensive. They don't allow you to store or save up the energy for later. Right. The main idea here, though, is that these generators are all doing the same thing, other than solar energy. Solar panels are a bit different, but everything else, whether it's coal power plant, it's a natural gas power plant, wind turbine, hydroelectric, geothermal, nuclear. Nuclear would be a non-renewable. They all involve this same model, right? Spin a turbine, spin a coil of wire past a magnet, moves the electrons in the wire. Now you have energy, you have electricity. Now, there's certainly different pros and cons of these different sources, right? And I briefly mentioned some, but in the next activity, you'll look into them a little bit more.